Assalamualaikum and greetings. My name is Wan Afif Haikal bin Razah. I'm from Section 3. For this subject, Manufacturing Sustainability, we have been assigned to conduct a comparative life cycle assessment of a manufactured good. For this task, we have selected conventional bicycle for our product. I will briefly explain about our introduction. For this task, we want to study on how products can be manufactured by emphasizing on their environmental impact from the production material and processes. In simple terms, this can be interpreted as can a product be manufactured from sustainable material and process. Next is applying technique that can be used for design process such as DFMA, DFE, LCA, and QFD. This is important to determine if it's possible to manufacture a product with sustainable concept without compromising the product performance and quality. We want to analyze conventional bicycle material selection by focusing on the sustainability performance of the selected material. And we want to improve existing production process through appropriate material and process selection. This can be done by analyzing our result and implementing our finding. As for our objective, we want to analyze the life cycle of the conventional bicycle. Next, we want to analyze the eco-design web for every component of the conventional bicycle. After that, we want to determine the environmental impact from the manufacturing of conventional bicycle. And lastly, we want to indicate areas of the product that can be redesigned to improve its environmental sustainability concept. For our scope, the scope of this project is to give more exposure and better understanding on the implementation of DFE from the life cycle analysis of a conventional bicycle, which consists of 15 components with mixture of metal and polymer material.
Assalamualaikum. My name is Faris Amshad bin Zulkifli and I will talk about literature review. There are 3 points that will be discussed, which are design of conventional bicycle, design for environment or DFE, and DFE principles and guidelines. First, design of conventional bicycle. Bicycle is first created in 1963 by a British engineer, Alex Moulton. Then, time after time, the design will improve and improvise until today's. Bicycle is a transportation device for a short trip. It is a small in size, so suitable for any living environment in the urban, suburb, or country. Its weight more than 14 kg, consists of frame, wheels, drivetrain, and simple brakes. Then, DFE. So what is DFE? DFE is an initiative that focuses on integrating environmental impacts, all while to reduce the cost too. Its main goal is to reduce or eliminate waste throughout the product whole life cycle. The waste aforementioned is all type of waste, either output waste or energy consumption and emission. DFE works by maximizing the use of the covered materials and energy by recycling or reprocessing. There are 6 principles and guidelines for DFE to achieve success. First, the principle A, ensure sustainability of resources. Then, to ensure healthy inputs and outputs. Principle C, ensure minimum use of resources in production and transportation phases. D, ensure minimal use of resources during use. E, ensure the appropriate durability of the product and components. And lastly, enable disassembly, separation, and purification. Then, the methodology. First tool that we use in tracing the carbon footprints of the product is eco-design web activity. It is a quick and simple tool. Its function is to analyze the product key areas qualitatively by displaying the data graphically. As you can see, the key areas that eco-design web activity covered is its product use, optimal life, end of life, material selection, material usage, and distribution.
My name is Muhammad Izharuddin bin Ahmad and I want to present about life cycle thinking. Life cycle thinking is a systematic framework for potential environmental impacts of product or service throughout the entire life cycle. Life cycle thinking implies on the understanding of the material that are extracted, processed, combined with other material to make part assembled into a product. Life cycle thinking also reduce product resource consumption and production while also improving socio-economic performance throughout its life cycle. Lastly, it is important to assess the LCT carefully and implies to it almost perfection so that the negative impact will be kept at the minimum. Then, eco-indicator activities. Eco-indicator activities is generally defined as a basic life cycle assessment method which determines the overall environmental effect from a product life cycle starting from raw material extraction to disposal. This method gives proper insight for designer to pick a product with minimal environmental impact in conjunction with a green design innovation. Through eco-indicator activities, there are three aspects need to be taken into consideration which will suffice the method requirement, which is human health, ecosystem damage, and resource quantity. This is the life cycle of the conventional bicycle. The material that used on conventional bicycle are rubber, steel, brass, plastic, and aluminium. For the rubber produced from latex, which is found in the sap like from trees and plants, a process called rubber tapping is used to harvest latex from rubber trees. First, rubbers go to the compounding, which involves adding chemical and additive based on the intent used for rubber. After manufacturing and vulcanized, it is ready to be distributed. Then, rubber is in high demand. Then, wood produce a large quantity of rubber waste, especially from old vehicle tires. Then, for the steel, begin with the raw material extraction of the iron ore by mining process. The steel will be produced by heating and melting the iron ore in the furnace when the impurities will be removed and carbon will be added. The steel produced will then be manufactured to its design and shape before it will be distributed and transported for use phase. The scrap of the steel from the manufacturing process can be processed again for a steel production. After end of life, the steel product can be recycled. For the brass was produced by the cementation process of copper and zinc, or that are heated until the zinc vapor is produced will be react with the copper. Thus, the production of copper begins with the extraction of copper-bearing ores. After extraction, the copper ore will be heated and melted to extract a metal like copper through smelting process. Then, after use phase of the product, the material will be undergo recycling process. Lastly, plastic production. Plastic begins with a distillation process in oil refinery. The process entails separating heavy crude oil into fraction. Each fraction is made up a combination of hydrocarbon chain of various size and molecular structure. Following manufacture, the material will be molded and shaped into a design to the product utilizing engineering data such as 3D drawing by using CAD software and machining. When a product approaches end of useful life, it becomes waste. But plastic is totally recyclable because it is made of a primitive natural resource.
Assalamualaikum, my name is Zaki Arif. I will talk about Eco Design Web Analysis. First, the scale. Green shows a very good attribute, while red is very bad attribute. To analyze, we pick two of the parts Eco Design to discuss here. The parts are seat post and pedal. Both show a different qualitative attribute. Seat post material is at a good scale, while pedal is at a bad scale. It is because it's made from steel, while pedal is made from plastic. Steel is 100% recyclable. It can be reprocessed and remanufactured without the use of toxic chemicals, unlike plastic. Thus, that caused the pedal's new ways of doing it at a good scale, as it has much room to improve. Overall, seat post shows a good and fine attribute, while pedal is not and can be improved. Now we're moving to the eco indicator of convenient bicycle. On the part, we follow the guideline of Eco Indicator 99 manual for designer. First, we calculate for the transportation before the improvement and after the improvement. From the calculation, we use truck and freighter oceanic as our transportation. From this analysis, we eliminate rubber synthetic and change the material used from plastic to carbon fiber. As the result, this total of eco indicator will be reduced. Other than that, we also reduce the mass of aluminium used by reduce the dimension of handlebar of the conventional bicycle. And then for the result, the grand total of eco indicator are reduced from 77,090.21 to 77,028.94 by 61.28. Thus, this will increase the sustainability of product and longer the life cycle.
Next, I will elaborate on the improvement of design. Based on the analysis above, the EcoWeb indicator shows slight improvement after being redesigned. The improvement that can be made to conventional bicycle is by changing the selection of material. For example, instead of using synthetic rubber for the tube, the whole tire design could be changed to a tubeless tire instead of conventional tire to reduce the usage of rubber material. Not only that, use of plastic for brake level product also can be changed to carbon fiber. Carbon fiber is completely recyclable compared to plastic. By doing so, this can help improve the sustainability performance of the bicycle. Lastly, for the conclusion, implementing sustainability concept upon new product will bring huge benefit toward the effort of reducing pollution as well as maintaining natural resources. The proposed sustainable activity have resulted in a complex yet ecologically optimized product. Several engineering methods such as design for environment, life cycle assessment and web indicator are taken into consideration in order to achieve greener production process. Eco-web indicator allows the designer to qualitatively analyze the product or concept to recognize the key areas to concentrate on as well as minimizing room for error. Sustainable design with the use of modern technology ensure continuous improvement of ecological environment as well as promoting the harmonious development between man and nature.